Hi students, very good evening. How are you all after a break of 1 week? I hope you are all doing well. And what is the development in physics? Did you solve any problems? How many problems you have solved today? Hi, very good evening. Hi friends, very good evening. How are you all? Jitesh, D'Souza, Akash, Deep, Shananya, Mansi, Smarnika, Radhika. After a gap, again I am meeting you all my friends. Hope you are doing well. And how is the development in physics? Are you doing nicely? Respond Jitesh, Akash, Shanaya. Shanaya, good evening. Mansi, good evening. Smarnika, good evening. Radhika, Jitesh, Akashdeep, everyone. Very, very good evening. I am very happy to see you all. Very nice to you all. So, in the last class, we were doing the problems on heat engine and refrigerator. Are you all comfortable? Hey, Jitesh D'Souza, why stress? You are a young boy. Stress you should feel. Fear about by seeing Jitesh D'Souza. You should not feel stress. Be brave. Fantastic. And did you solve any additional problems after the discussion of heat engines and refrigerators? It is a very damn important area, particularly in the thermodynamics. Hi Nikhil, how are you? Yeah. In the last class, I had given a set of problems in which I found many students have performed wrong for this problem number 2. An engine whose loco temperature is at 7 degrees centigrade has an efficiency of 50%. Initial efficiency is 50%. It is designed to 70% increase, means to increase the efficiency to 70%. What should be the hike in the temperature of the reservoir? Nothing but you know that in the engine you are having 2 blocks, source as well as sink. Sink is maintained at 7 degrees centigrade and you are asked to find by what temperature should the source should be raised to maintain an efficiency of 70%. First eta 1 by 2, T1 minus T2, 273 plus 7, 280 divided by T1. From this you will get the value of T1 previous. After that, eta dash given as 7 by 10, that is equal to T1 dash minus T2 by T1 dash. Again T2 is equal to 280 only. divide eta 1 by eta dash. You will come out with T1 dash as 933 Kelvin. They have asked not the value of T1 dash. They asked by what hike, what should be the rise in temperature. Rise in temperature. Present temperature minus previous temperature. 933 minus 560, which is equal to 573 Kelvin. Be clear in the concepts. And you should not commit any silly, naughty, petty mistake. You are fighting with 10 lakh students in JEE and 14 lakh students in NEET. So be accurate in applying the concept. Okay. Yeah, today we are into the next stage of the topic. This is dealing with the kinetic theory of gases. And let us analyze the kinetic theory of gases. First, dealing with the gas laws. Already you are well aware about the Boyle's law, Charles' law. In Charles' law, you are having two categories. Charles' law of volumes, Charles' law of pressures, and after that we deal with the ideal gas equation. So this is the summary for the today's session. We deal with Boyle's law, Charles' law, followed by ideal gas equation, then go ahead with the problems. As you are well aware that Boyle's law, at constant temperature, the pressure of a given volume of a gas is inversely proportional to the volume. P is inversely proportional to V, or simply PV is equal to constant, or P1 V1 is equal to P2 V2. And this is a law called as Boyle's law, dealing with the gases. P being the pressure, V being the volume, and T being the temperature, which is maintained constant. Now let us see different ways of drawing the Boyle's law graph. Taking volume on x-axis, pressure on y-axis, hyperbola. Taking pressure on x-axis, product of pressure and volume on y-axis, straight line parallel to x-axis. And in the third category, taking volume on x-axis, product PV on y-axis, it is again a straight line because you only told product of pressure and volume is a constant. In the next mode, again taking 1 by V on x-axis, pressure on y-axis, you will get a straight line. Pressure into volume being the constant. Very good. Next, taking 1 by P on x-axis, volume on y-axis, again you got a straight line. These are the 5 different ways of plotting the graph of Boyle's law. Generally, you may be knowing 1 or 2 pressure and volume giving the rectangular hyperbola, but you are supposed to have the wider knowledge of every law deep into the root. So these are the different ways of drawing the Boyle's law graph. When you observe the next one, the second sheet, this what I am doing. Yeah. So, these are the 5 different ways of drawing the gases equation related to the Boyle's law. Next one, Charles' law. What is this? Charles' law. In the case of the Charles' law, we have 2 different ways. Charles' law of pressures, Charles' law of volumes. So, we know that for drawing the Charles' law, first you should know the statement. Charles' law states that you have to maintain pressure constant, then volume is directly proportional to temperature, P is equal to constant, or V by T is equal to constant, or V1 by T1 is equal to V2 by T2. Whatever I have written, it is the equation of the state for the Charles' law of volumes. This is the Charles' law of volumes. And for this, again we are having different ways of plotting the graph. Taking temperature on x-axis, volume on y-axis, you will get a straight line passing through the horizon. Next one, taking temperature on x-axis, 1 by V on y-axis, you will get a rectangular hyperbola. Next one, volume on x-axis and 1 by T on y-axis, again you will get a rectangular hyperbola. And fourth one, taking temperature on x-axis and V by T on y-axis, graph is a straight line parallel to x-axis. In the fifth one, taking 1 by V on x-axis and V by T on y-axis, again graph is a straight line parallel to x-axis. These are the 5 ways of plotting the graph for the Charles' law of volumes. Similarly, you are having the Charles' law of pressure. In the case of the Charles' law of pressure, we maintain volume constant and there is a relation between the pressure and temperature. Pressure is directly proportional to the temperature, implies pressure by T is equal to constant. Like V by T is equal to constant, you will find the pressure by T is equal to constant. Again we have to plot the graphs taking pressure on y-axis and temperature on x-axis, and you will get the graphs like this. Pressure on y-axis, temperature on x-axis, it is a graph straight line pair passing through the horizon, and in the second graph taking P by T on y-axis and corresponding temperature on x-axis, you will get another straight line parallel to x-axis because P by T is equal to constant according to this law. Taking P on x-axis and P by T on y-axis, again you will get a straight line parallel to x-axis. So, these are the different graphs related to the Charles' law of pressure, in which volume being the constant, and after that we are having related all these gas laws. We are having the ideal gas equation where you will have PV is equal to N or T. Product of pressure and volume is equal to N, number of moles, multiplied by universal gas constant multiplied by absolute temperature. Now let us see the problems based upon the first phase of this. I am giving the first problem. An air bubble of radius small r rises from the bottom of the lake to the surface its radius becomes 5r/4. Pressure of atmosphere is 10 meters. Height of water column. If T is equal to constant, find the depth of the lake. Application based upon the Boyle's law. Clear? Samarnika, Radhika, Akashdeep, Josna, Yogesh, Radhika, are you following the lesson closely? Then record the problem. Application based upon the Boyle's law. An air bubble of radius small r rises from the bottom of the lake to the surface. Say for example it is a lake and the air bubble is here. It rises to bottom to top. Here its radius is r. After rising to the top, radius has become 5r/4. I want the depth of the lake. D is equal to H. Can you declare the answer? Now let us see. Let us apply the Boyle's law, and bubble under consideration is air bubble. So 9.5, fantastic. You have to apply P1 V1 is equal to P2 V2. P1 pressure at the top surface, V1 is a volume at the top surface of the lake. P2 pressure at the bottom of the lake, V2 volume. Given that atmospheric pressure 10 into volume of the bubble 4/3 pi into 5r/4 whole cube. Pressure at the bottom, say for example D is equal to H units, 10 plus H 4/3 pi r cube. By using this equation, you will be able to get the height of the lake, I mean depth of the lake, which is equal to H units. Once again, you have to apply Boyle's law. P1 V1 is equal to P2 V2. P1 pressure at the surface of the lake, V1 volume of the bubble at the surface, P2 pressure at the bottom of the lake, V2 volume of the bubble at the bottom, pressure at the top surface 10 units, volume 4/3 pi into volume of the bubble spherical, radius at the surface 5r/4 whole cube is equal to 10 plus H 4/3 pi r cube. When you solve this, you will come out with the height as H is equal to 9.53 meters. Got cleared? Shall I move to the next problem? Will you permit me for the next problem? How pressure is 10 plus H? Very good question. As you go deep into the lake, pressure increases. As you know, pressure in the 11th class, you had fluid dynamics. As you go deep into the fluid, here water, the pressure will be increased, and pressure at any point inside the fluid is equal to H rho g. Pressure is proportional to depth H already at the top surface atmospheric pressure is 10. Total pressure at this point, atmospheric pressure plus height of the liquid, that is nothing but P plus H, but P is already given as 10. So, this is equal to 10 plus H, 10 being the atmospheric pressure. Hi Arun, very good evening. Yeah, Jitesh D'Souza, got the clarity for the 10 plus H. Once again I am briefing. Pressure as you go into the altitude means as you are moving along the height away from the surface, pressure decreases. That is the reason astronauts used to wear a heavy suit which maintains the pressure that is similar to the pressure on the surface of the earth. If you go deep into the water, pressure gradually increases. Pressure at any point inside the liquid is equal to H rho g, H being the depth of the liquid. Total pressure at that point is equal to atmospheric pressure plus H rho g. I hope, Jitesh, now you got the clarity. Shall I move to the next problem? Will you permit me to the next problem? Thank you so much. I am moving to the next problem. A vessel has 14 grams of hydrogen and 96 grams of oxygen at STP, standard temperature and pressure. An electric spark is given and a chemical reaction is initiated. Reaction started, then the temperature is brought back to 273 degrees Kelvin. Then find pressure in the vessel. Find the pressure in the vessel. This is the good evening Arun. Sorry sir, today I leave school at no problem here, no problem. I was waiting for you. Yeah, now I am very happy. Arun, enter the game. Yeah, a vessel has 14 grams of hydrogen. 14 grams of hydrogen is equal to 7 moles. So, hydrogen is equal to 7 moles. And 96 grams of oxygen. 96 grams of oxygen means, tell me how many moles? 96 grams of oxygen means 9 moles of oxygen, and they are taken in a container. And this container is provided with an electric system, and charge is given to the system. Then when charge is given to the system, reaction is initiated, that is mentioned in the problem. And when once the reaction is initiated, then temperature is brought back to 273 degrees Kelvin. My question is, what is the pressure in the vessel? You are asked to find the pressure inside the vessel. This is the question. So, the moment spark is provided, hydrogen starts mixing with oxygen. Means every gram of hydrogen is mixing with 8 grams of oxygen. Every 1 gram of hydrogen is mixing with 8 grams of oxygen. So, totally when you observe this, after the reaction you are left with 2 grams of hydrogen. Every 1 gram of, so clearly, every 1 gram of hydrogen is reacting with 8 grams of oxygen. Every 1 gram of hydrogen is reacting with 8 grams of oxygen. So totally 12 grams. 12 grams is mixing with totally all 96 grams of, this hydrogen 12 grams is mixing with 96 grams of oxygen. Still how many grams of hydrogen is left? 2 grams of hydrogen, that is equal to 1 mole of hydrogen is left. Now applying the equation, PV is equal to nRT. In this equation, the volume of the container is fixed, volume is constant, R is constant, T is constant, P is proportional to N. Therefore, P1 by P2 is equal to N1 by N2. You are asked to find the value of P2. P2 is equal to P1 into N2 by N1. Now, when you observe this, the pressure at STP and NTP, that is clearly given. So, the pressure at the point, now you have to take. Shall I move to the next page? N1 is equal to total number of moles before reaction. N1 is equal to total number of moles before reaction, and N2 is equal to number of moles after reaction. Therefore, by substituting, you will come out with P2 is equal to 1 by 10 atm, that is 0.1 atmosphere. I will proceed to the next problem. Problem number 3. Gas is taken in a cylinder and pistons are joined by a wire. If gas is heated, then direction of motion of pistons figure will be this. This is a cylindrical container in which gas is taken, and this is a piston 1, and this is a piston 2. And both are connected by a wire. Inside this gas is there. Now, the question is, gas is taken in this cylinder and the pistons are joined. This is piston 1, this is piston 2. They are connected by a metallic wire or a small string, whatever it may be. And I start heating the gas. I am heating the gas. When I am heating the gas, my question is, in which direction the gas, the piston starts motion? In which direction? To the left or to the right, or keeping it at rest or none, whichever, moving to the right or moving to the left, and without any change they are at the same position, or None of the above. What will be your answer? I am waiting. Problem is on the board. A vessel has a gas is taken in a cylinder and pistons are joined by a wire. I am heating the gas and then the direction of motion of the piston. Your time is over. See, when you are heating the gas, you know that gas will expand. When gas expands, ultimately volume of the gas increases. Now, we know that when you observe the piston 1 as well as piston 2, piston 1 has more area when compared with the piston 2. Notice that area is more for piston 1 when compared with the piston 2. Because of this, force is equal to pressure into area. Force per unit area is nothing but pressure. Ultimately, here when you observe this, it is a application based upon Charles law of pressures. It is an application based upon Charles law of pressures, sir. It is an application based upon Charles law of pressure. Container is taken and in that gas is taken, gas is heated, ultimately pressure increases, because of which more force will be exerted. More force will be exerted on the piston with more area. So, the direction of the force this is the direction of the force. As a result of the direction of the force, this piston is made to move to the right. So, ultimately the first piston is start moving to the right, along with it will also take the second piston with it. So, the direction of motion will be right side. I hope you got the clarity. It is a conceptual application. When you are increasing the temperature of the container, ultimately gas will expand. Discussion, problem, next problem. Yeah, let us see the previous session contest question. A body is moving according to the equation x is equal to at plus bt square minus ct cube. X being the displacement, ABC are the constants. You are asked to find the acceleration of the body. By looking at this equation, it is very clear that the displacement is a function of time. So, velocity can be obtained by dx by dt. Acceleration can be obtained by dv by dt. And acceleration is equal to 2b minus 6ct. The winner of this problem, Salman, give him a big cheers. Salman will get an atom session free. Congratulations, Salman, congratulations. Very good. So, Salman is the winner of this contest. Yeah. So, by looking at this equation, you must be able to say the nature of the motion. It is a non-uniform accelerated motion. Whenever acceleration is a function of time, we knew that you are supposed to operate integral calculus as well as differential calculus. So, for non-uniform accelerated motion, this is the solution. Now, it is a time of contest for the next week. Note down the question. An air bubble doubles its radius on rising from the bottom of the beaker to the surface of the lake. Atmospheric pressure is equal to 10 meters of water. Then, what is the height of the water in the beaker? You are asked to find the height of the water in the beaker. Option A, 10 meter. Option B, 20 meter. Option C, 70 meter, option D 80 meter. I will see who will be the next class winner, who is going to get one atom section free. Yeah. Now we are into the next part of the lesson, pressure of an ideal gas. And we know that whenever you take gas in a container, the molecules of the gas continuously attacking the walls of the container, as a result of which they used to exert pressure on the volume of the container. The pressure exerted by the gas on the walls of the container pressure P is equal to 1 by 3 rho V RMS square, that is nothing but a root mean square speed. And kinetic energy per, when the molecules of the gas are in continuous motion, they possess energy by their motion called as kinetic energy. And kinetic energy per unit volume, half mv square by V, that is nothing but a half rho Vrms square. So pressure and kinetic energy are related by the equation P is equal to 2 by 3 times kinetic energy. Now we know that the gas molecules possess three different types of speeds: RMS speed, mean speed or average speed, and most probable speed. These are the three different types of the speeds associated with the gas molecule. RMS speed is given by root 3p by rho, root 3pv by m. But PV is equal to RT, root 3 RT by m, that is equal to root 3 KT by m. Such a speed is called as RMS. Mathematically we find the RMS speed. Mathematical equation is this: V1 square plus V2 square so on Vn square by n. And but in terms of the physical quantities like pressure, volume and temperature, we have these different types of equation for the RMS speed. The second one is nothing but average speed. We know that average speed is generally mathematical average. V average is equal to V1 plus V2 so on Vn by n. That is nothing but a mathematical equation of the average speed. But in this case we compute the average speed as 8p by pi rho or root of 8 RT by pi m, that is equal to root of 8 KT by pi m. These are the different equations for the mean speed. And most probable speed is given by most probable VMP is equal to root 2p by rho, that is equal to root 2RT by m is equal to root 2 KT by m. So these are the different speeds. Sangadi, which problem you did not understand? May I know? I will give a clarity. Sangati. I am waiting for you, Sangati. Which problem you did not understand, so that I would like to clear it. Okay. No message from you. I am pushing. Now let us see the problem on the speeds of the gas molecule and how we can operate the equations for solving them. Now when you take that container and in that container consider a collection of large number of particles with speed v. The direction of velocity is randomly distributed in the collection, then my requirement magnitude of relative velocity between a pair in the collection. Previous JEE application on this model. Consider a collection of large number of particles with speed v. The direction of velocity is randomly distributed in the collection, and then magnitude of the relative velocity between a pair in the collection. Say for example, let us feel that particles are distributed randomly, V1 bar, V2 bar, V3 bar, Vn bar, and in this, given that all are having the speeds v, v bar, their magnitudes are barabar, v bar. I will consider these two molecules because they asked between a pair. Let the angle be theta. Relative velocity is nothing but a difference, is nothing but a subtraction, vectorial subtraction. That is nothing but v1 square plus v2 square minus 2 v1 v2 cos theta. By putting the value, v1 is equal to v square plus v square minus 2v square cos theta. Finally, we will come out with 2v sin theta by 2. But average relative velocity is equal to 1 by 2 pi integration of 0 to 2 pi v relative d theta. That is nothing but 1 by 2 pi integration of 0 to 2 pi 2v sin theta by 2 d theta. Very good problem. Try to understand. And finally, after integration, you will come out with the average relative velocity is equal to 4v by pi. Now, the next one, degree of freedom. Generally, when you observe the gas molecules, they attain the internal energy by the molecular motion. This motion may be translational motion or rotational motion or vibrational motion. The possible number of ways of acquiring internal energy is defined as degree of freedom. Possible number of ways of acquiring internal energy is defined as a degree of freedom. This is different for different types of gases. For monoatomic gas, when you take a monoatomic gas, this atom can move along the x direction or y direction or z direction. So, the degree of freedom for it is equal to 3 translational degree. Means it has the motion along the line, so it can move any of the coordinate system. So it has 3 degrees of monoatomic gas has 3 degrees of translational motion. So the degree of freedom is 3. When you take a diatomic gas has 2 atoms. This combination of the 2 atoms can move either along the y direction or along the x direction or along the z direction. So translational degree is equal to 3, and this pair can rotate along the y direction as well as the z direction. So it has the rotational degree. How many degrees of rotational motion? 2. So the degree of freedom of a diatomic molecule is equal to 3 degrees of translational motion and 2 degrees of rotational motion. So degree of freedom for the diatomic molecule is equal to 5. Diatomic gas. Now let us see the triatomic. So in this, it is a non-linear. So for a triatomic, it has 3 degrees of translational and 3 degrees of rotational. So molecular weight of a mixture and specific heat of a mixture at constant volume, specific heat of the mixture at constant pressure, and when you mix the gas, all the 3 parameters will be affected. Its molecular weight will be affected, specific heat CV will be affected, specific heat at constant pressure will be affected. Now when you take a container having the gas in motion, it is in uniform motion. Suddenly if the container is applied the brakes and stopped, ordered motion will be converted as disordered motion. That disordered motion, that entire kinetic energy will be converted into the internal energy of the gas molecules. So that disordered kinetic energy will increase the temperature of the gas. So this is the concept of motion of a container having the gas. So brief recap of the lesson. We deal with the gas laws followed by ideal gas equation, pressure and kinetic energy, degree of freedom, and when a gas is taken in a container and that container is moving with a uniform speed and suddenly applied the brakes, the entire ordered kinetic energy will be converted as disordered kinetic energy, and the disordered kinetic energy will be stored in the gas as internal kinetic energy, thereby increasing the temperature. Thank you for joining. Have a nice day. Enjoy, and let us do few problems on the kinetic theory. I have given the best problems in your 10 best problems were given. Try to solve them. Have a nice day. Bye friends. Bye bye.